Hey guys, how's it going? My name is Devin Martin, and today we're going to be developing Craftsone, a game that I'm making. So, I'll show you what we have so far. It's quite modest. Here we go. We have a really big world that is generating as we move around here, reloading things. So, like this blue bush here with the two green bushes to the left, we can go way up here. It is unloaded. That does not exist anymore. We go back down, and it's right there. Right there. So, yeah, pretty cool. But those bushes are not actually anything. Hey, Joya. Those bushes are just part of the ground, and we don't want that. We want them to be entities. And the player is actually just drawing an at symbol in the middle of the screen. There's no player object or anything. So we want to create entities. That is what we're doing today. So let me move the Trello board. Where's the Trello board? Here it is. Again, guys, any questions about anything, definitely let me know. Okay, setup. So yeah, we're gonna kind of do these things. First thing, we gotta make an entity creation function. We're gonna call def entity create. An entity is just a dictionary. See, there we go, we've done it. Return the entity. We want to return them so we can store them somewhere. We want to give them some basic information first, though. We want them to have a component list and so a bunch of other stuff, but that'll be later on. Okay, we want to now make a few components. We'll just start with a position and a character component. So we'll say this will be a this is position, and the data, well, data is another dictionary. Let's do it like that. This will have X, Y, and that's it, I guess. Yeah, that's fine for right now, X and Y. We will copy that. We'll have a graphics char. This will have a few more. We'll have a character, which will be a question mark by default. Enough color, which will be... we kind of have to set up a color system, which is a little bit tricky. I don't know how exactly we're going to do that yet. Yeah, we'll just say... I'll do it like that for now. And we need a back color, which will be 0. Cool. Now we have a graphics char and position, which are two components. This is a list, so it's ordered. So we're literally going to store indices within the entities component list. That is going to be how we know what components we have. But we need to kind of backtrack this and make a dictionary where the keys are the names and the values are the indices. So we're going to say generate component map. We're going to say game component map equals, and we're going to use some fancy dictionary comprehension. Yeah, you know, did you realize that every single time I say map, what I mean to say is dict? And I say it a lot, don't I? Used to Game Maker Studio. Okay, there we go. So we're going to use some fancy dictionary comprehension, where the key is the name, and the value is the index, I guess, for, let's see, component in game component list. And really we need to say component name. I have to enumerate it. Index. Enumerate. Okay, so I will just display this really quick just to make sure that this is working right. And it should be fine. Boop, boop. Try that again. where's that print? Oh yeah, position 0, graphics char 1. Perfect. That's exactly what we want. All right. Now, we can say def entity component add. We'll give the entity and the component, and then the args. Well, we want quargs, right? Yeah, quargs. Okay. So check for component. So, well, yeah, add component to list. So we'll say if not entity component list. How do we say? How do we check if a list has something? My Python's slightly rusty. I'm slightly rusty, so. Yeah, I don't want that. Okay. Oh, I know how. I know exactly how. If not component. Oh, well, we have to get the index. Get component index. Component index equals, and we're going to use that map. Component get index component. And this is a method we need to write. Definition component name, or we'll just say name. And we will return game component dict name. That'll give us the index. Perfect. Okay. If not this in this, I would like to use these, I think. Okay. Then we'll say we want to append the component index to the component list. Okay, but that's only going to happen once. And then we want to alter, we want to set component values. So we're going to say for, oh, we have to get component data too, right? Yeah, which will use a similar function to this. Def component get data name. Well, yeah. Okay, and we're going to say return game component list component get index name data. Perfect. Okay. For data in component data, component data equals boop component. Cool. And that's going to be a dictionary. So we want to say data. We want to say key value in component data items. And I do apologize that I haven't written in Python for about 2.5, 3, or probably 4 months at least. Some of this is probably going to be a little bit shoddy. Entity. So we'll say entity. And we're going to kind of concatenate a string here. New key equals value. Well, equals quargs.get value, right? No. Key value. Yes. That's an interesting way of doing it. And this is going to say component plus underscore plus key. Fantastic. Right? Yeah, should be. All right, we're going to make some entities. We're going to say entity equals entity create. Oh. Okay, we're going to print entity and just see what happens. Okay, right here. There's our entity. Okay, now we're gonna do that again. But this time we're going to say entity component add entity. We want to add the position component. I did this backwards. I was checking if a list was in an integer, which of course it cannot be. Okay, so now we have a component list, a position X and a position Y. Okay, now what if I say, but hold on there, Buster, Y needs to be 66666. That's an uppercase Y, though. It needs to be lowercase. Then it works perfectly. Awesome. Okay, and then I can say, obviously I can say position X equals plus equals 5, and that will make my X position 5. Yes, cool. Okay, let's also add a graphics character. Yep, we're gonna make the glyph. Is it called glyph? It is not. Glyph. Okay. Glyph will be a that. Cool. That's all good. Oh, you know what though? Okay. So I need to make sure that any kind of value is copied. Check for copyable if how are we going to do that? We'll say new key, yeah. Say make the new key and set value. New key equals boop. And we'll say if type in. Does type just return a string? Oh, it probably says right here if I can. Oh, no, it doesn't. It doesn't. But I can still say list tuple dict then copy deep or copy shallow. Cool, cool, cool. Okay, that should still work fine. Fantastic. Okay. Otherwise, if I change the color of like a wall, and then all the other walls will change color too. But now it shall not. Say shallow copy. You know, I could just shallow copy all the data. That's fine. Because if it's a string or an integer, it just won't even be copied. Everything that needs to be copied will be, and nothing that doesn't won't. Yeah, that makes sense. Okay, set value. Okay, yep, cool. And honestly, well, yeah, we might as well just copy and set the value. Fantastic. All right. So now we have to try to remove components. We'll say def entity component del entity component. We need to get the. Basically, we're doing this again. Kind of. Yeah, we're doing this exact same thing again, only it's a little bit different. Remove. Is that, can I say that? Can I remove from a list like that? Is it pop? Python list methods. Because I know there's a way to just remove from a list. Is it just remove? Next is remove. Okay, it's just remove. That's easy enough. Why doesn't it give me like a tell me information about your method? I guess not. We're going to remove component to list. Remove component values. Let's see. Remove pop the values. And this is exactly the same. We just say pop, or rather we say cool. Okay. And honestly, we can just do it like this. We don't have to specify. Cool. So now I will remove the position. Component del entity position. Okay, and that worked perfectly. Now remove both the position and the graphics character. Great. All right, guys. Now we're cooking with peanut oil. I can remove that. We need to be able to define entity templates, which should be extremely easy, seeing as how we can just create them. So I'll say create entity templates game entity template list equal, we can call that a dictionary probably, right? Dict. We'll make that a dictionary. Yeah, honestly, I could just, yeah. And then we can make a function called, we'll say def entity template add entity. And that's just going to add a template. We're going to say, we have to give it a name too, though, or an ID. Well, we'll give it a key, whatever. We'll say game entity template dictionary. So Joya, how's you working on any projects right now? I saw your pixelated thing. Key equals entity. Cool. Cool, cool, cool. That works. So now we can say, well, really, what's the entity template make? And we can give it a key, right? Couldn't we? No, not well. We might be able to. We'll say parent equals none. We'll say create the entity. Say entity equals entity create. Add entity to templates. Key entity correct. Return entity. And we can give it a parent if need be. We'll say parent equals none. And we'll pass the parent. Okay. So now we can say, we'll say entity equals entity template make. We'll call this a human. What's the new project? Entity component add. We'll add this to the entity. We'll say this is a position. We'll make a character a graphics char. We'll make the char equal to an h. Sweet. So last thing we need to do is make an inheritance function, def entity inherit. Parent. Entity parent. Copy. So literally, we're going to iterate through each of the parents' components and just add them. So first we're going to let's see here, insert list. So we're going to say for component index in parent component list, because we don't want to just copy the component list. We don't want to override and just make a copy of the entity. We want to just inherit all of its attributes. And we're going to say if, well, we can just say, nice. You should have listened. I am right a lot of the time. It's good that you're starting now, though. Most people never make small stuff. And honestly, this is a pretty darn big project that I'm starting on. Crafts one's going to be huge. but I'm just going to develop it as a hobby. I'm not going to try to like make a ton of money off it or anything. So hopefully I can just kind of do it for fun and see what happens. Okay. Insert the list. So we have, yeah, if, well, yeah, if not component index in entity component list, well then we simply say entity component list dot append component index. Fantastic. Now, now things get slightly trickier. We're going to say for I guess key value in parent items. If not key in ignore key list, then we're going to say entity key equals value. And so we're going to say ignore key list equals component list. We'll add more to those as we go. This also needs to be a copy shallow. Okay, and we're going to add parent inherit. If parent entity parent, cool. So now we can say entity template get, or say human. I'm going to just make that function real quick too. We'll say def entity template get key, and we're just going to say return that thing. Let's try that. Come on. There we go. Oh, component dictionary. There's a component dictionary. But is there not? Ah, yeah. Okay, we need to obviously we have to make this down below the entity components because it's trying to call components that don't exist. How very fun. Okay. Okay, so we're getting somewhere. We don't have. We're not inheriting the. Oh, you know why? It's because it's glyph. Cool. It works. We inherited the entity we created, inherited from the human. We had all the human's data. Sweet. So, what do we have to do now? We have a somewhat functioning entity component system. We have the data part of it done. Kind of. So the player needs to be an entity as well. We're to say, figure out where this is being called. Stop. Okay. It's in here somewhere. Okay. Player generate, which is down at the very bottom. Player equals, it's going to be entity create. Entity template get human. And we're just going to set their position like that. We'll be good. Cool. That's perfect. Now we have to figure out a way of actually storing these entities. We need to actually birth the entity. Birth. Entity birth player. So that, let's close all this stuff. That's going to require a couple things. Def that entity. Okay. Okay, so this is something I have to decide on. Whether or not the entities are stored on a chunks grid, an entity grid, or an entity dictionary. I think a grid. No, the dictionary is going to be less data to store, I think. Yeah. Dictionary. We've never done it this way, but I think that this way is going to be perfect. Okay. Create entity data structures. So we're going to say chunk entity dict equals an empty dict. And then all we have to do is when we birth the entity, first we have to get the chunk. Say chunk equals world get chunk, or whatever chunk get. That's going to be at the entity's position x, the entity's position y. Add to chunk dict. Chunk dictionary. And then we're going to say, let's actually just get the x and y position like this. X, y, get position, x, y equals that. And we're going to say x. Well, we're going to say string x plus. We'll say pos to string. And we're going to say xy. That's a function we have to make in a library. We'll make a strings def. We'll call this string from pos. X and y, and we're going to just return x. Cool. And if you have any questions, Joya, about the game or about programming in general, just let me know. Or anyone, not just Joya. Okay. Equals entity. Cool. That works. Yeah. Seems pretty good. Although we should have two different functions. Def entity world add to entity. And although do we need this? Yes, we do. No, we don't. Doesn't seem like. I know I've always done that in the past, but I don't see a need for it right now. Okay. So last but not least, when we're generating a chunk, let's stop generating the trees. Don't want to do that anymore. Let's choose from a wider array of characters, though. Okay. And we want to, yes, when we're drawing in the view drawer, don't want to do that anymore. We want to find, because it draw the ground, draw entities. So first we're going to say entity equals, and we're going to say chunk. We're going to say entity at, and we're going to give it a position. We're going to say string from visit pos. We're going to say real x, real y. Entity at, we need to make that function. Div entity at x, y. And we're going to say return. So first get the chunk, get chunk. And honestly, it's pretty much this. It's the same function. When we're returning this. Okay, we're returning that, only we have to call it with a get. Get. That's why. Cool. That should work. So entity at is going to return entity or nothing. We're going to say if entity is not equal to -1, draw glyph x, y, entity, graphics, char, glyph. F color. Okay, let's see what happens. Probably gonna get a crash. Or we're gonna see a human in the middle of the screen. Nope, we got a bunch of issues. Oh, there's no world. Right. Because we're calling this pretty early. Do we do it before the We're doing it before the world is done. That's kind of frustrating. Yeah, okay, so okay. So we're gonna actually do this. Well, that doesn't work either because okay, so if we don't call this all is dandy, correct? Correct, sort of. Entity at missing requirement. Let's account for that first. Real X. Oh no, we're just getting in a position. We're doing this. Entity is not defined. Where? Okay. Right. So in the in this, is that where the kerfuffle is? No. It's in the logic module. Entity at. So the no, yeah. We are doing something when we shouldn't be. We do not need to do this. Right? Here we go. Okay, cool. And our player is here, we just cannot see them yet. Well, no, they're not there. They have not been birthed. So what we need to do is, upon creating the chunks, we want to create the player. I want to check if the player's birthed. I guess. If not or not entity is birthed, game player. We're really going to need to say player get because that's going to need to be a function. Player get return game player. Okay. Player get. If not, yep, then entity birth player get. Okay. And the way that this function can work, let's see, to just determine if the player's birthed somehow. That's going to be entity. We're just going to say if we have to get all this information as well. I reckon that's going to do it. Oh, we didn't. Right, we have to say get. Okay. So that's nearly there. I just don't think it's actually birthing. Does that work? No. You go away. No, I don't want that. It might just be helpful to have a little tag on the entity that is birthed. Which let's just do that real quick. Entity is birthed equals false. When we inherit, we ignore is birthed. And then when we birth them, yeah. Entity. It seems fine. And then up here, all we have to say is birthed equals true. Yeah. Uppercase T true. Why is that not working? You know, it might be working. It might not. It just might not be. Let's see here. Print hit. See if we're getting a hit. Oh, we are. Okay. So it's not a problem of whether or not our... you know what the problem is? I bet it is... I don't know, we're looking at the real position. Real x, real y, entity at. And I guess we're always getting -1. Is that's the issue? Oh, no. Wait a minute. We're going to say draw ground. It was working the entire time. We were just drawing the ground over it. That's the problem, I guarantee. Yep. Okay, cool. So now the players moving their position is just not updating, which is fine. We can quickly, well, let's quickly make an unbirth function. Just copy and paste this. It's pretty similar. Unbirth. We get the chunk. We say okay. And so what we can do is, that's the problem though, is okay. So we're gonna make a function called chunks update. Chunks world. Okay, and that is going to be def world chunks update. That's going to say all this stuff. And now we can call this. Yeah, this is good. We can call that once before it's called in the execute world game state event. We could do that right when right when the players generate, or right when the world is generated, I guess. We can do update chunks, and then birth player. And honestly, we can just update the, well, yeah, birth player, get player get. That should work. Watch it crash. Come on. What happened? Did I do something awful? Did I crash the whole computer? No. Did I? What happened? Okay. Is there just, what? Okay. Okay, I did crash. Player. I see. So we need to just get in here, in chunks update. Yeah, just get player. Get player. Am I only? Whatever, yeah. Equals player get. That was hopefully the only problem. I just know why it's so slow all of a sudden. I'm not sure what happened. Radius is also undefined. Okay, why? Yeah, we need to get that in there. I forgot that. Okay, world generation volume, generate, chunks update. Oh, is it being all recursive? No, it shouldn't be. Oh. Ugh. Okay, yeah. That's fine. We can do this stuff outside of that, I guess. Rather not, but we can. It's fine. We can do that outside of this. Still not liking it. Name entity get is not defined. Oh, what am I? Oh, what? Entity get player get. What's that even supposed to be trying to do? Entity birth is what it's supposed to say. Don't know why I put get. Okay, that took a minute, but we're good. And now we should be able to unbirth them every time. Okay, entity unbirth player. Entity birth player. And well, that might make us move. Fantastic. Okay, we're moving. We physically exist in the world, and we are physically moving. Great. We can now create other entities, and they'll automatically be stored, and everything will be fantastic. There's one problem. There's many problems, but there's one that is going to be extremely obvious, which is it's not a huge deal. Let's see here. So general ground, yeah, whatever. Generate entities. So we'll say for index range, random range, for I'll do like 0 and 8. Entity equals entity create. Hello. Entity template get tree. We'll say oak tree. We'll say entity position x equals let's say chunk at real x. Well, let's get this better off because this is a little bit confusing. Cool. Okay. Real x plus irandom range 0 chunk size. We'll say entity birth entity. We just have to make a oak tree template. We'll just say it's a tree. We don't have to be that specific yet. We'll give it a nice tree icon. Do those tile names, buddy. Okay, yep, it has that. And it is a, say, f color equals, we'll say, just 0, 255, 0. And by golly, we might have some trees, physical entity trees that are everywhere, and should be good. Should be good. Do I just have like so many instances of the game open or something? Entity birth. Oh, I think it's because it is. I'm trying to birth it in a chunk that doesn't exist. Still some problem. Chunk x plus times chunk size. Huh. So in this case, the chunk doesn't actually exist yet. Oh yeah, it doesn't. Fantastic. Okay, that's fine. We should really be doing all this generative stuff after anyway. So we'll get rid of this, get rid of this, and that. Okay, it's fine. And then when we call chunk generate, well, actually, so we'll chunk generate chunk. Then we'll call this. That'll all be dandy. That's fine. And this needs to be called chunk create. Okay. Create. Generate chunk. Chunk generate chunk. I'm not holding my breath for this one. Oh, I should have though, because it worked perfectly. Fantastic. Problem is, when I walk into these trees, they disappear. Because there can't be more than one entity on a tile right now. And if there is, it, you know, destroys it, because it overrides it. So we have to fix that, among many other things. But that's going to have to wait until later, because I'm going to be done streaming with some food. I'll probably stream again in a couple hours. Thanks for watching, everyone, and I'll see y'all later.